All right, hello everyone. Thanks for joining today's live stream. I'm here with Nate Bright, who's a mechanical design engineer for Tesla. Nate, thank you for taking the time to join us today live.
Thanks for having me. I'm super excited.
Would love to hear from you all where you're calling in from. We're currently located in Reno, Nevada. We're actually calling from a town called Lemon Valley, which is slightly north of Reno. And we just hit the time zone change, so we're going to be getting an extra hour of daylight every day, which is great if you need to work late or socialize after work. But I think it's going to be a little bit challenging to wake up early this week.
It's a bit of a trade-off for sure.
Yeah. And what the plan is today is Nate has spent some good time to make a presentation for just general advice on mechanical design and working as a full-time engineer. So we're going to be going through that presentation that you made. And a fun fact about Nate and I, we both started as interns before we transitioned to full-time at Tesla. And I personally find that's a really neat opportunity to get exposed to full-time engineering work. With your internship, Nate, how would you overall explain the difference between interning at Tesla versus full-time, like being full-time at Tesla?
Yeah, well, first I'd say for sure the internship experience is a great bridge. It's a great way to get experience in a role and also meet a team and have a chance to make an impression on the team. And the beautiful thing about an internship is that the experience cutoff tends to be lower, right? Like you're able to gain an internship with less experience than you would need to gain a full-time role, which is, the point of an internship, right? And so, yes, the internship experience is fantastic. As for the difference between the two, I think it's it's just more responsibility and taking it to the next level when it's full-time. But the cool thing about Tesla is that they really treat interns as if they are full-time engineers, so you get to learn a lot. But really, at any company, I think an internship is a great thing to pursue.
How large was your intern group when you interned, if you remember?
It was actually pretty big. I don't remember the exact number, but we're talking hundreds, hundreds of interns, and it was cool because they put us all in a similar housing space, like apartments that all the interns lived at. So it was a cool environment. But
looks like we got John Mijay, Manuel, Raul. Would love to hear where you guys are calling in from this fine Sunday morning or afternoon, depending on where you are. Yeah, for the internship, I think just for Nevada, for my crew, we had about 80 people. But then with Texas, with Fremont and Berlin and all the other areas, I think it was well over 300 or 400 people. So it's a pretty large group.
For sure.
All right, looks like we've got London, Georgia. That's where I grew up, Omkar, if it's the state in the U.S. Rapid City. Rapid City, that's not Michigan, is it?
Grand Rapids is
Grand
Michigan,
Rapids
yeah.
is Michigan. Okay, yes. We got Canada, San Jose, New Jersey. Oh, we got a couple people from San Jose. Oh, it looks like... Oh, yeah. Where in Georgia, Omkar? I grew up in Lawrenceville, if you know where that is. Ontario, Canada, Arizona.
Oh, you're in Vancouver, near us.
Yeah.
Just up very
just
nice.
north.
Cool.
Does Canada have the time zone change? I know the U.S. does. I don't know if Canada does.
I don't know. Maybe they can let us know.
Oh yeah, Swanee. Okay, I was very close to Swanee. Dude, Swanee Town Center. Swanee's this little town in Georgia, and they've just renovated their town center. So you have all these restaurants, a nice park.
Yeah.
I'm sure you've been there before, Umkar, but it's one of my favorite places to visit when I go to Swanee.
Yep, looks like there's a time zone as well. Time zone change.
Oh,
So,
yep,
perfect.
yep. We got Todd calling in from Reno.
Awesome,
Represent.
Todd. Represent.
Awesome. Well, I'm gonna hand it off to Nate, and he's gonna go over his presentation just to go over some design advice and tips. So let me go ahead and pull that up.
Cool. Sounds great. Thanks, Dan.
Of course.
Yeah, so today we got 3 main topics to talk about, and each one has a big picture principle, and then we'll take a chance to look at how it applies specifically to mechanical design. And after every section, we'll have a time for a Q&A and maybe get a question or two, and have a conversation about what we covered. The beautiful thing about mechanical design, it's heavy on the details, but at the same time, when you can start to grasp the big picture, it just unlocks so much more. So let's dive in. We'll go over to the first, just my journey. I started, my first job was picking beans for my uncle. So he was a farmer, and so I would work summers for him. But first one that was more of in a professional setting was civil construction. So I dug ditches, drove skid steers, laid water main, that sort of thing. And it wasn't an engineering job, but it's what opened up future opportunities. So I always love to encourage people to, even if you don't have the job exactly that you're dreaming for right away, just get into something, and the career can take you beautiful places. Howmet was the first engineering space that I worked. It was a continuous improvement role. And then from there, I interned at Tesla, full-time with Tesla as an associate mechanical design engineer, and then now a mechanical design engineer. So it's been a fantastic journey. And I always like to share this with people when I have an opportunity. When you think about what you want to do in life, this is super helpful when you're thinking about a career, but really it's a great thing to keep in mind anytime. I think there's 3 big pieces that fit together to find something that you just love in life, love doing. This is something that I used and I found it very helpful. But those 3 things are your passion, your skills, and your mission. And if you can find something that combines all those 3 things, oh man, you've got it made. It's a golden opportunity. So just
pun intended, I hope. With that
yeah, exactly. I work for the MADE team at Tesla, which stands for Manufacturing Automation Development Engineering. So we design equipment for the Tesla manufacturing lines. So there's lots of puns on MADE. But yes, passion. So what is something that you would do just for fun, even if you weren't paid for it? You'd volunteer your time 40 hours a week to do it, or maybe 30 hours a week, but something that you just love. You love doing. Skills, a good way to think about this is, what are some things that you could do in 10 minutes that it takes other people an hour to do? So everyone is wired differently, and everyone's got different skills. And so identifying what you can bring to the table is pretty powerful. And then the last thing is your mission. Like, why are you here? Like, what's your point on this planet? What is something you'd give your life for? Whether that means like you'd live your life for this goal, or maybe even more extremely, like you'd be willing to die for this cause or something. It's kind of more of an existential question, but it's a powerful one. And so yeah, if you can find something that matches all 3, it's where you want to be. But just to make sure it's kind of explained these 3 things. For example, if you had passion for something and it fit your mission, but you didn't have skills to do it, you could start into it, but you definitely want to find a way to boost your skills, or else you wouldn't be effective with it. Maybe something it fit your mission and you had skills for it, but you didn't have a passion. Then over time that'd get very old, and you'd easily get burned out because you didn't have the passion fueling what you're doing. Or maybe you have a passion for it, you really enjoy it, and you got the skills for it, but it doesn't fit your mission. I like to joke at that point that you're really effective at wasting time. Not really. I mean, that's maybe a too blunt of a way to say it, but if you want to link what you're doing to some purpose, something bigger than yourself. So that can look so many different ways. I know some people that are really passionate about developing communities. I know some people that are really passionate about helping world peace, or helping with decrease world hunger. Those are a number of beautiful missions to connect your life work to. A lot of people have the skills and passion to make it happen. I know for me with engineering, part of what I was so excited about with the mission was the opportunity to help companies thrive here in the U.S. and be efficient enough to preserve blue collar jobs. And so when you can do that, you help people make a living. And so I think that's part of my mission. And then also, I think for me, some of the mission side also is I love Jesus, and so I love the chance to help people and spread his love all around the world, right? And part of that is helping people have great jobs and be able to provide for their families. So yeah, it's a little bit of that.
Quick question regarding passion. I've heard a lot of people, and I've even struggled with this. How do you, with finding what you're passionate about, like design engineering or engineering in general, when did you realize that engineering was your passion, and what did you do to get to that point of realizing that?
Ooh, that's a great question. For me, it was job shadowing. So I had an opportunity to do some job shadowing and see some people do engineering in action, and it's often you don't know what you love until you experience it for the first time, right? So I think job shadowing is a great thing to find things that you love, and it's equally effective to find things that you don't love. You thought it would be awesome, and then you job shadowed and you go, ooh, maybe not. And that's also just as valuable, because then you can pivot and find something that you do love.
Yeah, something my dad shared with me is when sometimes you don't know you're passionate about something until you've put in a little bit of effort and blood, sweat, and tears to grow in that skill. And then either from that you'll find, okay, I have the skills and I'm passionate about this, or okay, this is not for me. Let me try something different.
Yeah.
So I think job shadowing is a great way to find that. It's great.
Yeah. Give things a try. It's worth going for. So perfect. So that's I always just love taking a quick moment to show that Venn diagram. Okay, our first big topic for the day is the topic of growth, and I've found growth is so important when it comes to engineering, especially in the early phases of the career, but really at all times. Building the skills and knowledge base that you have allows you to be so much more effective in the future. I wanted to give this illustration here. Imagine that you're outside on your deck, and up above you there's these little stars that are showing up above your head. They're a little bit too high for you to reach just standing, but they're kind of up here. And your goal is that you have to collect as many stars as possible. You're just trying to go around collecting stars. And this is an analogy of being in the workplace and being given an assignment or a task or some project that you need to accomplish. You have all these stars that are above you, and you have to collect them. And one approach is for you to go get your ladder and move the ladder over to that spot, climb the ladder, get the star, come back down the ladder, and then a star shows up somewhere else, so now you got to move your ladder, go over there and grab the star. And this would be an illustration of you don't have the knowledge to complete the project at first. So you go talk to someone and you just have them tell you the answer. For example, I know I need a sensor to sense my product, but I don't know which sensor to use. So I just go talk to the electrical engineer and he tells me what sensor to use. Or I don't know what material to use for this, or what coating to put on, what finish to put on my custom part. So I will just go talk to a senior engineer on the team, and they'll tell me which one to do, and I just do it. So on the one hand, yes, you completed the project, you got the star, you moved your ladder there, you climbed the ladder, got the star. But the problem is that if you ever have to get a star in the same spot again, you'll have to move your ladder back to the same spot. If you have to specify that same sensor in the future, if any of the circumstances have changed slightly, you're going to have to go ask the electrical engineer again, because you don't really understand what's going on. You just got a brief answer and just plugged it in. So with our illustration here, instead of just moving the ladder, it's going to be more time intensive and it's going to be harder up front. But it's better if you can take the time to just raise the level of your whole deck. It's gonna be some hard work. You're gonna have to put in some big columns. You're gonna have to put your sheeting across a larger area. You're gonna have to put guardrails all the way around. But if you can raise the whole level of your deck, well, at that point, all the stars are just in reach, and you can just run around collecting all the stars much more rapidly. And in the same way, in the workspace, if you don't know something, I view that as the biggest opportunity. That is golden time. If you don't know something and you need to know it for your project, this is the opportunity to really dig in and learn the why behind. And that will allow you to not only be effective in that one project, but then every other time that comes up in the future, you already know it.
So it's taking the time to build that foundation, so you're not just task oriented, but you're setting yourself up to make larger decisions more effectively rather than just relying on other people.
For sure. And this is why growth for engineers is so rapid at the beginning of a career, is because they're forced to learn a lot of the background of things in order to do their job in the first place. The first few years in a role are a ton of learning. But it doesn't have to stop then. If you keep the mindset to keep asking the why and learning the big picture behind all of these things, you'll keep growing your effectiveness as well. So yeah, let's take a look at an example of this.
Chicago represent, love it.
Hey, nice. Yeah, so let's take a look at how this might apply to sensors. This is a topic that comes up in mechanical design, especially for automation equipment, because you always have to sense your product. So in automation equipment, you always want double checks and verification of where everything is located, whether your product is actually in place or not. And so we have a couple of different styles here. One of them is called the through beam, and it's a very simple principle. You can expect that one side is a sender, it sends a laser through, and you have a receiver that receives that light. And if a product comes in between, it interrupts the beam, and your sensor detects that a part is present. So pretty simple. You also have something called like a retroreflective. In this case, the top sensor is both a sender and a receiver. It emits light. It bounces off of a reflective surface. So think of like those, like a reflective vest that you might have on when you're biking. That similar type of material on the one side, and it reflects the laser back, and it detects its own reflection. And if it fails to receive a reflection back, you know that something came in between and blocked it. So that also is about part presence. The diffuse reflective is a little bit different. Instead of it expecting to bounce off of a reflective surface, it actually is meant to reflect off of the part itself. So this one, maybe you have a metal block and it will just shoot a beam, bounce off the metal block and go back to itself, and it will sense it. And if it sees something in the spot, then it knows the part is present. Then the last style that we'll talk about is that we use a lot is an inductive proximity sensor. So what's going on here, you've got a barrel sensor and it has a magnetic field on the end. And whenever something comes into that field, it changes the magnetic field around the tip of the sensor. And so it has to be ferrous materials work best. So if it's steel, some type of ferrous steel, that has the most effect on the magnetic field. But whenever that magnetic field is interrupted, then the sensor switches on and says, I can see something. I'm detecting a product. So these are a couple ways that we do part presence. And if any of you guys are in mechanical design for equipment, I'd encourage you to take a look at a couple of these brands. I'm actually going to send a message here in the chat that includes a number of brands that we use here at Tesla, but they're not, I mean, they're standard brands for these type of sensors. Bailiff, SICK, IFM, Keyence, and they have some phenomenal catalogs on their website that you can read the spec sheets on these various options, as well as all about part numbers and product numbers. So if you're involved in this, I'd encourage you, don't just move the ladder, build your deck and take some time to dig deep and really understand why these sensors are used. So
question with sensor selection, Nate.
Yeah.
What have you found is the biggest mistake design engineers often make when selecting these different types of sensors?
Ooh, that's a great question. I think the one of the biggest mistakes is choosing a sensor just because it's convenient for mounting, but not thinking about how the sensor actually works in sensing the product. So for example, if you guys notice this diffuse reflective sensor, this one's pretty handy because you only have to mount on one side of the product. So you can shoot in with your laser, reflect off the product, and it bounces right back. You don't have to have anything on the other receiving side. So you can imagine when you're packaging this into a machine, it's pretty handy. However, there can be some issues with that. That can be sensitive to the reflective or the emissivity of the surface on this guy, or even the color can be an effect. So you have to be careful what sensor you specify. But even more specifically, I'd love to take this a step deeper for everyone on the call, because this is something that's worth putting some real thought into. Sensors are bound to fail at some point. Either the cord gets worn out if it's on an end of arm tool, or maybe the sensor gets bumped and it is no longer aligned correctly. And it's critical that that thought is put into the sensor selection beforehand, so that those little mistakes don't cause a catastrophic equipment crash or failure. So this is actually a gentleman that's on the controls team of my team at Tesla, and he said something that was pretty profound, and so I wanted to put it up for everybody. But the overall principle is that bad sensor positioning or operation should not lead to equipment action. Having a sensor misaligned should never allow the machine to move. The machine should only move if it gets a positive signal from your sensor, and that positive signal should only be able to happen when everything is correctly aligned and functioning properly. So to illustrate this, let me give you guys an example. Let's say that you have a an overhead gantry that is delivering product to various stations. Maybe these are little heating coils or something, and you need to bring in a product and put them in these different spots. So you know that I need to detect the spot on these heaters so that I know if the product is there or not. Because if the product is there, then I don't want to bring another one in because I'll crash. I'll smack the overhead gantry will try to put a product into a space that's already occupied by another product. So you'll have a catastrophic crash and cause some significant damage to your equipment.
I found this happens more than it should in manufacturing.
Yes.
Would you say that's true?
I would say so. And I think what we're going to talk about today is actually one of the reasons. So that's why it's so important. Let's say that you decide to go with the retroreflective sensor. So you've got just to remind everybody what that means, we've got a sensor here. It's emitting a light that bounces off the product and goes back and is received by the same sensor. And if it detects this product, if it receives light back, then it assumes that the part is present. So in our first station, it emitted the light, it bounced off the product, and so our machine reads the part is present, so do not place a new part. That's a success, we're good. In the second one, there's no product there, and so it sends out a laser, it emits the light. It doesn't hit anything, so it doesn't reflect back, and so it reads part absent. You are safe to place a part, which is correct. We're all good. However, we have some issues here if, let's say, this sensor gets bumped, which it is guaranteed to be bumped. Like you cannot assume that it won't be bumped. With all the maintenance and stuff that happens, even the best techs, at some point something's going to get bumped. And so if this sensor gets bumped, it's now shooting off up into the sky, and it is not reading anything, even though the part is here, because it's been misaligned, so it's now missing the part. And so what the sensor reads is part is absent, place a new part, when in actuality the part is there. And so this overhead gantry is going to zoom over here. It's going to forcibly come down and smash these parts together, and you're going to have a downtime. So this is an example of not following this maxim, right? In this case, bad sensor positioning did lead to equipment action. And so that's setting yourself up and at huge risk of a equipment crash. However, there's ways we can solve this just by switching to a different sensor style. So what if we used through-beam sensors? So step one, in the first situation, you've got a sensor that's emitting a laser on one side, and it's being received on the other side. So if there's something in the way, then it successfully reads part present, and it doesn't place the part. So we're good, that's correct. If there's no product in the way, it emits the light, receives the light, part is absent, we can place a part, we're all good. But now let's say that your sensor gets misaligned, it gets accidentally bumped. Now your emitter is shooting up into the air, same situation. However, at this point, instead of your misalignment allowing your machine to move, now your misalignment prevents your machine from moving, because it no longer receives the light on the receiver, and so it assumes that a part is present. Another way to think about this is you want to assume that the part is present until you get a positive verifiable signal that it's not, and then you're safe to move the machine. You always want to assume the dangerous case and only move your machine if you can verifiably prove that you're in the safe state. So yeah, this is a great example of a time when, even though both sensors successfully detect the part or show that there's not a part there, through-beam sensors are a much more robust solution, because it ensures that any misalignment will cause your machine to stop rather than misalignment causing your machine to crash.
I find this to be a very impactful point. And at least for me, I found with mechanical design, sensor selection like this is not really taught. Do you find in general with like your internships and starting at Tesla, do you find learning these concepts, did you have to kind of dig for them, getting to know other engineers and learning from them, or is this something that was taught to you?
Yeah,
from the start?
I did. In fact, this was born out of many conversations with our controls engineers and electrical, and they actually got to the controls people actually said, hey, we need to talk about this, and they gave a presentation to the mechanical team to talk through some of these differences, because I would highlight that if you're just talking about a mechanical perspective, sometimes it's really annoying to have to package a sender and a receiver. Like it is sometimes hard to fit this into your machine. So it's often, you would wish that you could just use a reflective one. But from a controls perspective, it's important to use the sender receiver. So
yeah, really, really impactful point.
Yep. Also, I see a nice chat here in the chat about using Keyence for part checking contact patterns on gears. Exactly, yeah. Keyence actually sells a lot of great products beyond just basic part presence, whether it's present or not present. They actually sell a whole suite of inspection cameras, and I mean they're a huge supplier. So yes, great. That's a great application.
I saw that the end stop switches on a 3D printer. Yeah, bad alignment or dust can cause the tool heads to crash.
Yep. It's exactly, you want your, if the sensor is not working properly, if at all possible, you want to design it so that it fails in a safe way. Fail safe. You want it to fail by not moving rather than a failure leading it to it moving and causing a crash. So yeah, great points here. Perfect. And any Q&As here on the, any Q&As from that topic? Let's see, there's one about light curtains as well. Light curtains around the gantry to avoid even human-machine collision, especially for safety and fast-paced work with cobots. Yep, great use. Light curtains are phenomenal for safety. Just keeping people out without them having to lift up a physical door. That can be a great design choice.
What are your thoughts on cobots in general for manufacturing?
Ooh, so at Tesla we don't use them much just because a lot of the product is some bigger ones, with the drive unit and some of the battery packs. The product is very large, so you really have to have something with more capacity. Although, so I know some of the cobots do have some bigger capacity. I know also one of the things that we've struggled with is that if you have a cobot, often the speed has to be tuned down so that it can safely work around a human, as well as some of the speed has to be same thing. The speed has to be reduced so that you don't so that if it hits something, it has the sensing to stop right away. So we've found more success with having safety zones where a human does the part they need to do, and then they get out, and then the robot just goes to town with full speed. However, I know there's some really good applications for cobots in different manufacturing spaces, so they definitely have a good place as well.
And a cobot basically means you can work in the same space as that robot?
Yeah, exactly. Okay. So it often has force feedback in its joints, and so if the joints ever see a force that's higher than its limit, which would indicate that it's trying to move into something and it can't, because it's colliding with something, it has force feedback in the joints to where it will immediately stop, or it will stop trying. And so it can safely work around people, because if it hits them, it will just stop instead of crushing them. So that's why they call them a cobot, right? Working alongside.
Gotcha. Makes sense.
So neat. Well, we'll keep monitoring the chat, but I think good to go on to the next one?
Let's move on.
Okay, sounds good. Let's talk next about first principles thinking. This one is I'm super passionate about this topic because I find that it allows you to go from a place where you're just doing what you've always done, or just doing a maybe something you don't fully understand. It both helps you become more knowledgeable, but it also helps you get better solutions. So the basis of first principles thinking is that you want to distill everything down to what the actual goal is. What are the first principles that we're working with? In just ruthlessly distill it down. You say, okay, here's what I've been given as my task, but why are we actually doing this? That it's a big question of asking the why, and it allows you to break it down until you know this is my actual goal, and then at that point you can find the best solution to that. So let me give you a practical example, but first I want to talk about what might be some of the opposites of first principles thinking. Tradition is a good example of an opposite of first principle thinking. So this is how we've always done it. Now, perhaps that is the best way. That's not to knock tradition. Often things are a tradition because they work. And if it works, sometimes you just go with it, right? But if you don't ask the why, then you'll never find anything better. So that's one. Also, assumptions. If you assume, oh, I always need to do this a certain way, but you haven't thought about the why behind it. That's another example. And then also shallow knowledge. If you don't fully understand the question, you don't fully understand the problem, then you'll never be able to come up with a better solution. You'll just be stuck doing what's always been done, or you'll be stuck doing something that works, but it's expensive and it's harder than what you could have come up with if you more fully understood the problem. So that's the theoretical, but let's take a look at an actual example of this. So this is hypothetical, but it's also not hypothetical. This is pretty representative of things that can happen. So let's assume that you are told that you need to retool this robot cell, and specifically you need to add a product nest to this station. And that's all you're told. You're like, hey, I need, your manager or someone comes over and said, hey, I need a product nest put onto this robot station. So you say, okay, let's get to work. And you say, okay, how do I make a place for this robot to put product down? Well, I would need a nest. I need a product nest to hold this product. Okay, so you design a V-block nest to hold that cylinder. And then you say, okay, now I need to mount it to the top of my robot station. And so you decide to go about it with a dowel system, which is a great way to locate product in an automation equipment. Great way to locate things to each other. You basically have a base plate, 2 dowels put into the base plate, and then your receiving part has a hole and a slot. And the hole in the slot makes sure that you never over constrain your parts, but yet you can still precisely locate them. So that's shown right here is what a hole in slot would look like. And here's if I was going, there's a Google image of a nest. Okay. So you decide, okay, I'm going to do this. I custom design my nest, but now I need to install it. And if I'm going to install dowels into the top plate of this robot station, you're going to have to use a CNC to put in your precision holes for the dowels. It's not really something you can do by hand. So you're going to have to take this plate off, ship it to your CNC. Hopefully you have an internal CNC, but if you don't, you have to send it out to a fab shop. They'll add the holes and the tapped holes for the bolts, and then send it back to you. You reinstall it on your machine, and you're good to go. So that works. But you'll take multiple days for the turnaround on the plate, most likely, unless you pay to overnight expedite. And also you've got a custom part here that you're taking some time to design. You got the job done, but what would have happened if we dug deeper at the beginning, when we first got the task, what would have happened if we had asked ourselves, what's the actual goal here? What are the fundamentals that I need to distill this down to? So let's say we when our manager gave us this task, we just took a few minutes. This literally can take 2 minutes, but you just dig a little deeper, you ask a couple questions, and before long you realize, okay, what he initially asked me to do was to just put a nest onto this station. But the reason behind it, like what's the fundamentals we're actually trying to accomplish? Well, in this case, we need to redesign this station so that the robot can place rejected parts. So they're bad parts. We're not going to be using them again. We're rejecting them. Rejecting parts aside so that a human operator can come and remove them from the cell. Okay, this gives us so much context, and it allows us to come up with a much better design that fulfills the requirements, but is much cheaper and faster to install. So what could we do? Let's say we still want a custom designed nest. Fair. So we have a nest that we designed. However, we say, look, if all the robot's trying to do is place it into this nest, and we don't need to pick it out again, we're only placing, and then a human is going to come along and take it out. Well, we don't need locational precision for this case. You need locational precision when the robot has to pick from it, or if it has to place precisely. But in this case, if you make your V big enough, your robot can be a little misaligned when it comes in for that placement, or the block could be in a slightly uncertain position. But when the robot lets go of this product, it's still going to go into the V. And since the human is the one picking it out, it's not the robot that has to pick it out. You don't care if your block is a little bit off. In fact, with let's say you're mounting it with M6 bolts, a standard through hole for an M6 bolt is 6.6 millimeters in diameter. And if you have an M6 bolt, that's 6 millimeters in diameter on the shaft. So you now have 0.3 millimeters in any direction that your block can shift, assuming that your holes were machined in perfect positions. So 0.3 millimeters is actually pretty precise, especially if all you're doing is putting a product into a V-block that a human is going to take it out of. So at the end of the day, you don't need dowels. I mean, dowels are something we often use just out of tradition, and often you do need them, but in this case you don't. So let's assume we got rid of the dowels, we still make a custom block, but now, instead of having to ship the top plate to a CNC machine, we just go in there with the drill, we drill some holes, and then either we field tap the holes in the top plate and we install our block, or even more even more crudely, we just drill a hole and put a nylock on the back. I would suggest you tap the plate, but you don't need the dowel. So now at this point you've saved a lot of time.
Bro, can I just add something to this?
Yeah, please do.
When I was even today I'll make this mistake, but when I was starting off at Tesla, when I was designing this, it was some fixture, I even forget what it was now, but I chose some really complex steels. I made all these fancy surfaces and extrusions and cuts because I thought, man, I gotta prove myself. I gotta make sure this design looks super good, which I think aesthetics is important, but bro, like even just hearing this now, man, like designs that I've done and designs that I've seen,
yes,
this can save hours. This can save so much money, like thousands of dollars.
It can.
So that's all I wanted to add.
Yeah, 100%. And this is all unlocked because we took time at the beginning to actually define what the goal is.
Yes.
Actually define what the goal
like
is.
Like first principles thinking, like you said.
Yeah. First principles thinking, exactly.
I feel like this topic of first principles thinking is, at least I've seen it's not taught enough.
Yeah, I think so. But I think part of what's so challenging is first principles thinking. You need a little bit of context to put it into principle, you know,
because it's based on the project specifically, right?
But nonetheless, you can still develop the mindset. Just asking why, right? It's and not in an annoying way like why, but just like, hey, let's dig the next level deeper.
What's that tool, the 5Y? Is that the
Oh,
same
true.
thing or is that different?
It's getting at a similar principle.
Okay.
That's looking at a root cause analysis of why did something go wrong.
Okay.
So you ask why until you get to the root cause.
Gotcha.
Um,
So similar but not the exact.
Similar.
Okay.
Yeah, exactly.
Sorry to interrupt back to
No,
what
this
you were
is
saying.
phenomenal. This is phenomenal. So I want to take this one step further, and this is humorous, but it makes the point. Okay, so who says we even need a custom nest at all, right? What if if all we're trying to do, again, we're going back to the basics. All we need to do is we need a place for the robot to put rejected parts, and then a human is going to come and take them away. If that's all we need, then hey, I mean, a garbage can would solve the issue, right? Granted, you would want to fix the garbage can in place so no one moved it, but you could just put a garbage can next to this thing, and the robot just swings around, drops it in the garbage can, call it a day, you know. And
30-minute project from a potentially like multiple day.
Right, exactly. You have
Yeah.
no custom machining. You just go buy this thing from Home Depot, you know. So would I actually just put a garbage can next to a robot in the factory? Maybe not, but the point is that I could, and it would still solve the point. It would solve our goal. And so this is so important to help get simple designs, and it makes a big difference as well. And kind of as a side note, I would also mention this is the same true with quality inspections. So whenever people are talking about quality inspections, sometimes they want to just add more and more quality inspections just because. But a good question to ask is like, what are we actually going to do with the quality data that we gathered with this sensor? So if someone really wants to measure the height of a product, that sounds like a great idea, and it probably is. But let's say it's really expensive to measure the height. Well, then we really should ask the question, what are we going to do with this height data? If the height data is off, are we actually going to reject the part? If we are, then great. But if we're not, if we're just measuring it for no reason, well, then maybe we should save our money for something else. So it's always trying to ruthlessly distill down to the fundamentals of what's going on. Perfect. Well, I think this is the end of that second section, so let's take some time for a question here. I think there was one.
There was
up
a
in
good
the
one
chat.
up here.
Yeah.
I can highlight it up here.
Cool. How did you make the transition from a manufacturing engineering role to a design engineering role? And what strategies would you recommend to someone who is looking to do that? Nice. A great question. The transition for me was a steep learning curve. And actually my situation was a little bit different, so I don't know how representative it could be, but I worked my internship in manufacturing engineering, so it's more of the high level stuff, reviewing quotes for whole lines and concepts. And I did some design work, but it was pretty limited. And then when it came to transitioning to full-time, the team actually did not have a manufacturing role available. They only had design roles available. However, it was like an entry-level design role. However, the internship had gone well enough that they were willing to hire me into that role. And so what I would encourage people is that the willingness to learn things rapidly and to pursue new things, it opens up opportunities even if maybe you don't have all of the technical knowledge at first. Because it's true, when I first started mechanical design, I had a lot to learn, but I had shown in the internship that I was willing to learn very rapidly. And so that's what really made the difference on actually having that opportunity. But when it comes to how would I suggest someone making that move, design engineering is a different skill set than manufacturing engineering. They're both extremely important and they're both difficult in their own way. Manufacturing engineering, you have to keep track of a lot of the big picture, especially if you're leading an entire project. Design engineering, you have to have a lot more just specific knowledge on everything from just all the technical parts of your fits, your tolerances, your best practices, your design decisions. So I would encourage you, if you're in manufacturing engineering, start paying attention to the details of your equipment. Start talking to the designers. See if you can sit in on their design reviews, and start paying attention about what works and what doesn't. And honestly, be encouraged, because when you make the transition, you're going to have such a great big picture knowledge from your manufacturing engineering background that you're actually going to be an asset to the design team. And so, yeah, go for it. I think you build out your technical knowledge in the specifics, and I think you'll do really well.
Bro, something that was so confusing to me, this was not just Tesla, but this was previous internships.
Yeah.
Was job titles.
Yes.
A manufacturing engineer at, say, ZF is different from a manufacturing engineer at Tesla.
True.
Which is
True.
potentially different from... So how... Do you have any tips for people with learning what the titles mean? Like, what would you say there?
It's true. I mean, especially the term manufacturing engineer.
Yeah.
Like, talk about broad. It can mean everything from sustaining existing equipment to being a program manager for a new equipment. It can literally mean so much.
Because my title for a while was manufacturing equipment engineer.
Yep.
But what I did was very different from even a manufacturing engineer on your team.
And some manufacturing engineers, instead of building new equipment, they might be like an expert on die casting, right? Or an expert on one specific process. So, yeah, I guess the only advice I can give is when someone uses the term, just ask them what they mean, like what they're actually referring to.
Yeah, just don't be afraid to ask questions.
Yeah.
That's good.
Ask the questions.
Good stuff.
Cool.
Good questions, guys. Keep them coming.
Okay, let's go into the third. Concept here. So the third topic I'd love to present to you guys is disciplined reasoning. This is all about tracking in your own mind, and sometimes even writing out on paper, the way that different requirements connect. This is applicable to mechanical design especially. You'll always have different constraints in your product. Maybe your machine has to be a certain weight, or a certain height, or not too tall, or maybe you have ergonomic requirements for your machine. So there's always things that are connected to each other. If I do this, then I must do this. Or my choice here affects my choice here. And understanding how those things all link together will allow you to optimize that whole system of decisions. This is true in mechanical design, but it's also true in manufacturing engineering in the sense of big projects, right?
Yeah.
So if I choose this equipment, then I'm going to need this conveyor. Understanding all the links, and then is what allows you to optimize the whole system. So let's take a look at an example. End of arm tool design. So I love designing end of arm tools. It's a fun technical challenge, and when it goes well, you just get this sleek tool on the end that can be it's a ton of fun to design. But it can be a little bit of a lot to take in at the beginning. Like, how do I know, where do I even start? Where do I even start on this design? So one way to help you know where to start is to start exploring what are the interdependencies between my design decisions. So let's start with the robot. Here we have I actually don't know the brand of this robot that's pictured, but we got like a benchtop robot. It's very possible a cobot also, considering that the way it's mounted. But we have a robot, and so we need to ask the question, how do we know which robot to order? Okay, a couple pieces that go into robot selection. Robot selection is influenced by the range of motion. Oh, perfect. A universal robot. Thank you. Appreciate that. So a robot is informed by the reach that the robot needs. So how far are all the things away that it needs to reach to? That'll influence it. But a big one too is the payload. Your robot is limited by how much you can attach to the end of the robot. So you can't pick your robot until you know the mass and the moment of inertia data for your end of arm tool. Otherwise, you won't be able to size your robot. Okay, so now we know that before we can pick our robot, we need to design our end of arm tool. Sounds good. Well, how do we design our end of arm tool? Well, we can't. The end of arm tool is what. Let's say you have two grippers, as shown in this picture. All the weldments or boltments or however you configure everything is heavily dependent on what grippers you choose, the size of your grippers, the mounting pattern on your grippers. And so you can't design your end of arm tool until you've chosen your grippers. And you can't choose your grippers until you've designed the fingers that you mount to your grippers. And you can't pick you can't design your fingers until you know the product that you're gripping. So ultimately, before you can pick your robot, you have to start with your product. What is the product that you're gripping? It's really the same concept as when people design skyscrapers, how you design in general from the top down, because you can't size your foundation until you know how much weight is above it. And so you'll start working structurally from the top to the bottom. So in the same way, you start with your product and you work your way back towards the robot when you go through your designs.
My mind, when I think of robot design and end of arm tooling, I would have thought initially the other way around.
So it's fair.
I like this thinking because you're saving yourself time and trouble in the long run, right?
For sure. Exactly.
Cool. Great knowledge.
Exactly. So a couple design tips. Actually, Dan, can we do you mind, well, I'll leave this up, but do you mind sending the links while we go?
Got you.
So I just wanted to give a quick rundown on how I approach end of arm tool design. I will start with the product and take a look at the size of the product and how much the product weighs. And from there, you start to get an idea of how you want to grip it. If it's a circle, then maybe you're going for a V block on both sides that's going to grip this product. But either way, you start to get an idea, and you'll just make a very rough design of the fingers you want to use to grip your product. You're not doing any details at this point. You're just doing the basic shape. Then once you have your fingers, you're going to want to pick a gripper that generally can fit the size of your how far the stroke of your fingers that's needed to pick up your product. And you'll want to double check the capacity of your gripper to make sure that it can grip hard enough to hold your product. So that's a big piece of it, but also that the moment loads on your gripper are not too great. If my gripper's here and I'm holding a product way away from it, the moment loads on my gripper are going to be enormous. And so that is a big challenge. So you want to keep the product close to your gripper to reduce your moment loads. And then you'll want to check to see, make sure it solves. And we sent a couple links in the chat. Just want to make sure it will eventually work. But the Schunk is one company that makes pneumatic and electric grippers, and they actually have a phenomenal sizing tool that once you have your product information as well as your finger design, you can actually size the gripper. And so this is a great tool. And the nice thing is that even if you don't use Schunk as your preferred supplier, you can use this to gain a general idea of how much force and moment capacity your gripper needs. And then you can go buy a gripper from Festo, from Zimmer, from another supplier of pneumatic or electric grippers. So,
Schunk for the win.
Schunk for the win. Yeah.
Anybody ever intern or work there out of curiosity?
That would be cool.
That would be cool, wouldn't it?
Yeah. I don't know. Our team often uses Schunk. We've found them to be perhaps a little more expensive than some of their competitors, but also a solid product. Zimmer is also some good stuff. Unfortunately, we've not had great experience with Festo grippers, but
Oh, interesting.
I think they do have some good uses, but we
Yes.
just have had a harder time with them. And then also, there's another link here that we sent. It's the robot sizing one. This one is super handy. There's a Excel sheet out there that is actually published by Fanuc, and this is a spreadsheet that you put in the information about your end of arm tool, the mass of your end of arm tool, the moments of inertia of your end of arm tool, and then it actually calculates whether or not your robot size works. So if you're using Fanuc robots, it's a phenomenal tool and really is helpful. So I wanted to share that to
I didn't
you
even
guys.
know those existed, to be honest.
Oh, it makes your life so much easier. It's really a great tool.
That's cool.
So, yeah, let's switch to the next slide. I think, yeah, just wanted to remind everyone that when you choose your gripper, you're going to want to think about the capacity, which is like how much can it hold. Making sure that you're gripping something hard enough so that just friction alone can hold it so it doesn't fall out, or you have some sort of mechanical locking so that it holds it firmly. But don't forget that when you're using a robot, your acceleration is greater than 1g. So if you zoom up, you now have to account for both the acceleration of your robot and acceleration of Earth's gravity. So when you do your calculation for friction force between your gripper and the product, you want to make sure that you take that into account. Yeah, exactly, like a V-clamp. That's a great way. And that's helpful. This is whenever you have a circle that's gripping a circle, this is actually, it seems like you'd want to do that, but at the same time, it's actually very challenging because you don't know where along the circle you're actually making contact. In principle, you'll only be making contact on, between the two grippers, you'll only be making contact in 3 spots that fully defines. And it's if you're perfect, you might make contact in more than that. But if you try to grip with circle on circle, you don't know where along there you're actually gripping, and there's a lot of uncertainty about where your product actually exists in the gripper. With V-Blocks, it's absolutely rock solid, the same every single time. If you have a V-Block with a circle, you know it's contacting right there and right there. You've got it.
And that's this picture you have here on the...
Exactly, yeah.
Yeah, nice.
So if you're gripping something with the circle, tend to go with V-Blocks. That's a good design choice for your grippers. Yeah, I think I would, if you guys want to do more research, I would encourage you to check out some of those links, as well as check out the website for some of these gripper suppliers, Schunk, Zimmer, and Festo. And you can also, there's a lot of different robot manufacturers as well. KUKA, Fanuc, as well as some of the smaller cobot ones like Universal Robot that we took a look at.
Should I, what, the Schunk part number? What's this for? Should I
Oh yeah,
send
let's
that?
send that.
So what's the background here, Nate?
Yeah, you want to switch to the next slide? This is
Yeah.
the last point on the end of arm tools. So if any of you guys are currently designing end of arm tools, I just wanted to show you this product because it is so nice, and it unfortunately is not super advertised on their website, so I wanted to highlight it. Schunk has this brilliant system where you can actually have these quick change features, and typically what happens here, Dan, if we can go for the if everyone can see my mouse, you'll notice that there's a finger right here. However, there's a bolt that has to go through the finger and into the gripper. So you're not actually able to have the finger go straight out from the gripper. You kind of have to have this L so that you can have a place for your bolts to go through the finger and into the gripper. This is pretty standard for most grippers, and even some quick change systems still require you to have space to bolt in your bolts and from this direction, which can be annoying. Sometimes you just have to do it. However, Schunk has this brilliant system that allows you to avoid that. You basically have some quick change pins that get installed into the gripper side, and then on your side they have specific machining instructions for how to machine certain precision holes into whatever custom finger you already have. And they have some hardware that has like a button press that will either engage or disengage with those two quick change pins. And so
it's super fancy.
It is, but in the end, a couple benefits. You don't have to have space for a bolt to go through your finger like this. You could just come straight out from it. And then the other perk is that you have a quick change opportunity. So you can take the finger right off, just literally click of a button, and you can bring another one in and just stick it right onto your robot. So that's a nice feature. So I would encourage you guys to take a look at that. It's the BSWS-URM product line with Schunk, and it's just another thing to put in your tool belt to have as an option. Good question here. What's the function of the bolt? Is it to hold the gripper fix or something else? So the bolts, what they're doing here is they're holding the fingers onto the gripper. That's exactly correct. In some way, you have to secure the finger to the gripper, and this is the standard way. You bolt through the finger right into the gripper, and there's threaded features on the gripper side. But like I mentioned, it just means that you have to kind of have an L shape in your finger, which is fine. I think often that's a great way. Keep it simple, keep it awesome. But sometimes you start to design your finger and you realize it'd be really nice if I could just go straight out with my finger instead of having an L. And in that case, I haven't found another system besides this Schunk option. Other companies have quick change features, but you still have to run a bolt through the finger in the same orientation at the end of the day. But by allowing you to machine your features into your custom part, yeah, it's pretty slick. So cool.
I know our audience may have things coming up, and there was something I wanted you to touch on that you had on your presentation.
Yeah. That
had to do with connections with people.
Sure. Yeah,
that's something you wouldn't mind.
Happy to. Yeah, we'll wrap it up here pretty quick. Let's talk about this last thing though.
Oh, that was the next slide. Nice.
Perfect. Yeah. So, I guess the punchline here is, I think your interactions with people are so critical. There's so much about engineering that is technical and data driven, but at the end of the day, you're working with a group of people. And anything you can do to improve the relationships with your coworkers is investments you're making in the efficiency of your team and also the morale of everybody. It's so important. One of the I tend to like talking to people in person. I found that the communication is often better, the understanding is often better. And so one of the things that I try to go by is I'll send Teams messages or emails if I just need a quick answer, or if it's just like a quick yes/no, part number, quick question. But if there's anything that's deeper, like a concept review or anything, I love to try to do it in person. At least a video call, but in person is even better. And I mean, this is not. I like to say if you're messaging with someone on Teams, and it's gone beyond 5 instant messages. So if you've asked, they responded, you've had to clarify, they tried to clarify their answer, and you still don't understand, and so you're asking like a 5th question, a 5th message. It probably would have been better if you had just gone to talk to them in person. And that's not a hard and fast rule. Everyone's got their own style. But I think that's a helpful way to build strong relationships with your coworkers and help out with that. I would also say that when you treat people well, everything goes better.
True that.
True that. I mean, if you're viewing people like an obstacle to your progress, or if you're viewing them as just like gears in the machine of the company, that's going to get old. And you're living life 50 hours a week with these people, or more. And so I think anything you can do to treat them well is so important. Yeah, so I always like to highlight that. I think it's an important point. So, for sure.
What's the best way to learn and practice this skill? Because it's more of a soft skill, right?
It is a soft skill. I think you gotta start doing it. Start doing it with little things. So go and talk to someone. Go walk up to their desk and ask them a question in person. But it's an interesting question. How do you care about people? Man, that's more of like an existential question. Like how do I learn to care about people? Yeah, I think you can take a utilitarian approach and say, if I care about them, then they'll care about me. So I guess that's maybe that's one approach you can take, and it's fair. You can care about people just for the utility of it. But I think it's also powerful to take it deeper. If you have a reason to take it deeper. I mean, for me, I care about Jesus. And so I care about people, right? Like Jesus has made such an impact in my life, so I love people because of that. But I feel like there's many other reasons to go for a deeper reason of why to care about people, even beyond just the utility of the fact that they'll be nicer to you if you're nicer to them. So I'd encourage everyone to take some thought, even on their own in their own life. Like, why do I care about people? And but it definitely makes a huge impact in the workplace and helps everything run smoother when you treat people like people. And yeah, it's so important. So
There was a question here that I thought was pretty good. Theo, yeah, this one. Curious to hear what other solutions you have for ID handling. So I was just replying in the comments. Maybe you're relying on friction. Maybe the reason you're gripping the ID is because design has literally said, hey, you cannot touch the outer surfaces
right.
of the
I
part.
mean, for example, if he's picking up gears, he can't do an OD grip because he'd be messing with the teeth.
Yeah.
Yeah. So an ID, if you've designed Navarm tools, looks like you probably be aware of these ones, but there's a number of grippers that are designed for ID gripping. Typically a 3-jaw gripper is a good approach, and they'll have like narrow fingers that come down like this. They'll have your gripper up here, and then it comes down like this, and there'll actually be 3, and your gear would be like this, and it reaches down inside and it expands. If you view it from the top view, you would have 3 jaws that go out and in like this. So your jaws will expand to grip the ID of your gear, and then retract to make space. So that's something I'd recommend. Take a look at some of those. A 3-jaw is a great one. And then you can either do just like a purely friction grip on your product. So make sure that the grip, the force of your gripper is enough that when you grip the product, your friction force is sufficient to not drop the gear. But also often gears will have there's some feature in there where maybe if we're viewing it from the side, here's a cutout view of your gear, and you have the finger coming down like this, and maybe you include a little lip on your finger design. So the finger is going out like this, and there's friction on this surface here. And that is you design your gripper so that this friction force is sufficient to hold your gear. It's sufficient. However, maybe as an extra bonus, you include this guy underneath, so that if this ever were to fail, the gear would just fall down onto that lip, and it wouldn't fall. And then when your finger closes, then of course you would design it so that the stroke of your gripper is such that the shelf comes fully away from the ID of your gear, and then can come away from your gear and leave it where it's sitting. But yeah, the 3-jaw grippers are pretty handy for ID gripping, so I would take a look at that.
Got a good question from Kevin here.
Okay, I work around a lot of engineering teams, but I also see they are pretty stubborn. When you Oh, yes, when you project your ideas, how do you work through that, especially if you are a member and speaking to a manager? Oh man, this is a phenomenal question. Okay, so I've found that this actually goes back to first principles thinking, and helping your team also achieve first principles thinking. So most engineers can't, yeah, there's times engineers can be stubborn, but hopefully they're also data driven. So if you can if you can guide the conversation at first to really define what are we actually trying to do? What are our goals? Not just what is this solution that we did before that we're applying, but like what are our goals? Here's what we're trying to accomplish. And then once everybody understands that, then you can say, hey, I have this idea, and it very distinctly solves the things that we're trying to solve. And in fact, it's cheaper or easier than the thing that we're currently proposing. And so that can be a good approach. And the other thing I would encourage you to do, if it's possible, the people that are holding the decision, like maybe this manager, see about talking to him before there's a group meeting. If you bring this up in a design review in front of everybody, especially if the manager was the one who originally had this other idea, it can be a little harder for him to swallow his pride and just take what you're saying. But if you have an opportunity to talk with him offline beforehand, kind of talk through the idea, get his feedback, maybe come to a solution that's a compromise between and maybe better than both of your decisions, then when you come to the group, you're already synced up and you've already got him on your team. So that's like kind of a people person thing I would suggest. Don't be afraid to talk to people one-on-one before the big meeting, and it often allows the big meeting to go a little bit better. So
that's really good advice.
Yeah, that one's been helpful for me. So cool.
Do you want me to pull up your contact information here, Nate?
Sure. That would be great.
Let's do one more question here. I see one from Karan.
Yeah, and also just contact. Well, we'll pull up the contact info in a moment. So yeah, feel free to reach out if you guys have any other questions. Also, says if you try to bring people around to first principles thinking, how do you bring them together without seeming condescending or without seeming like you're stepping into their lane? Yeah, that's a great question too. A lot of it is tone of voice, but if you part of it's tone of voice, but also part of it is the relationship you have with them before. This is why I talk about how you treat people beforehand. If you've been chatting with this person about the skiing they did last weekend, or showing interest in their family, like, hey, how's your kids doing? All of these things connect you as people. And so then when you have to tackle something like this, or maybe there's a disagreement, you have a better foundation on which to approach it. But as specifically to this question, I think asking questions in a mellow, measured tone of voice that communicates curiosity rather than judgment is very important. So if you and I are disagreeing about something, using phrases like, hey, tell me more about that, or can you explain some of the reasoning behind that one? Or can you explain what the goals are that we're trying to get here? And sometimes it's still going to be a little bit awkward, but that's okay. It's okay for there to be a little bit of awkwardness. But yeah, helping as you work through that, and also having a context beforehand of like being connected as people, that helps a lot. But ask questions. Yeah. Just dig deeper.
And know that you're never, whenever you're questioning a solution or a problem, you're never attacking the person, because oftentimes if people challenge a solution that I've implemented, I make sure to really understand and know, hey, this is not an attack on me. This is just, this person generally wants the best solution for the team and for the company.
Yeah.
So having that mindset and also whenever you're challenging someone's project or solution idea or concept, be the way you word it, like you were saying, Nate, come across in a way of, hey, I'm not attacking you. I'm just trying to question some of the solutions that you've brought up, or the way that you want to tackle this problem. And that's hard because I feel people always, and me naturally too, I feel it's an attack because I spent so much time on this.
You just put out your baby there with this potential solution. So yeah, it's true. You gotta separate the person from the technical details, both when you're receiving feedback and also when you're giving feedback to others.
And a small way that you can help with this, that I've seen at least, is communicate, hey, that like maybe there's certain things about his concept or idea that's great. So you compliment those. You say, I really love this. Or, hey, this other solution you had worked really well for these reasons. Do you think we could take that and apply it here? So you're actually complimenting him while trying to also get your point across. So it's sometimes a little bit of a game that you got to play.
Yeah,
right?
it could be tricky. So I mean, I love the question. Thank you for putting this on here because
really, really good question.
It's a real thing. So,
well, Nate, thank you so much for setting up this time and
for sure
putting the time into this presentation. This was awesome. And everyone joining, thank you so much for participating and asking all the great questions. I'm going to share Nate's contact here. So currently works at Tesla, lives in Reno, Nevada. So if you guys are ever in Reno, please reach out to Nate or myself. We would love to meet you in person.
Yeah, for sure.
Anything else you want to share with this information here, Nate?
I just say, like, anyone who's on this call, you always have some phenomenal potential ahead, and I'd say keep learning as much as you can. Take every project as a chance to instead of just moving your ladder, build your deck, build your foundation with every project. Learn to distill down to the fundamentals of what's actually trying to be solved, and that'll allow you to get even better solutions. And then make the connections in your mind between your design decisions, and treat people like family. And there's a beautiful future ahead for everybody. So I'm super excited for all of you, and thanks for joining us. This was awesome.
We'll see you guys for the next stream. Please send us messages on LinkedIn of what you would love to see next, whether it's recruiting, design, PLC controls, anything. We would love to help you guys out. We'll see you on the next one.
Cool. Take care, everybody.